In this video, we want to talk about the debugging facilities provided in Visual Studio. Now, we're not going to cover every single feature. As we go along throughout Module 102, we'll discuss a few more of these facilities, but I just want to cover the basics so we can get started. Firstly, you can set breakpoints, and so let's say right over here, I want to set a breakpoint. You can left click, so you have this bar to the left. You can left click in there to set that breakpoint. It's this red dot here, that will indicate a breakpoint. You can also press F9 to set a breakpoint on that line, so where the caret is currently at. That is basically where the execution of your program is going to pause. So this is currently set to debug. If you go to debug, you can run without debugging. It's going to print all of this stuff out. Basically what's going to happen is, you see we have int x. Here I incremented so it's 6. Then in this for loop I actually print something else out, so I print out I. Down here I call this function and I pass it x, which is 6, and it's just going to print that out again. Of course, if we run it as we have done it, we will not get that pause in execution. What we have to do is we have to go debug and start debugging. Then we get all of these windows that pop up. So we'll get a slightly different configuration. I'll just stop that by clicking right here. Then you can also click on this button right here, Local Windows Debugger. Of course, you can just press F5 instead of Control F5 for run, as we have done it many times before. So it's just F5, or once again, you can click this button right here. If I bring up the console, that we have not printed out anything yet. So you get your actual console, your window will come up, and you also have, once again, all of these other menus, which we'll talk about as we go along. So on this red dot, you can see we now have this arrow, and that is on this line now where we do this increment operation. Again, I'll talk about how we can watch some of the values in using some of these menus later on. I just want to do kind of one thing at a time here. So what I'll talk about first is up here, we have a few buttons, right? Firstly, you can stop debugging by clicking stop debugging, of course. You can also restart. So let's say you move on in your program and you want to kind of go back and again restart. Instead of clicking stop and then clicking that start debugging again, you can just do restart. We'll look at that in a bit. Okay, next I want to talk about these three. These are important and might be a bit confusing at first. So what I've done is I've provided a summary in a slide, which I'll show you next. For your notes, I have the summary here. So we have step into. This is going to advance the program execution one statement at a time. So basically, if you click step into, it's going to execute that statement. Then you have step over. The function and thus the statements within that function is going to execute, but you don't have to step through it line by line. So that is what step over is useful for. We also have step out. Now step out is going to resume program execution until the current function returns. So basically the program execution is going to resume in the calling function. That is useful if you step into a function. Now again, functions can get very complex, and instead of stepping through that function statement by statement, so going through all of these statements, you can say, okay, I've seen enough in this function and I want to go out of it. It's almost like breaking out of it. It's more like, okay, it's going to execute the rest of the function, right? So that code is still going to execute, but you don't have to see it. You don't have to manually go through it. It will return once again to the calling function, and then you can continue stepping through the code. So this is more useful if you are already within a function and you want to return once again to the calling function, whereas step over is going to step over the function completely. That doesn't mean it's going to step execution of the function. Execution once again will still happen. You just won't step through it line by line. Okay, back in Visual Studio, our program is executing sequentially, right? So we can see we are over here. Now, by the way, that means that it is on this line, but it has not executed this line yet. So it is basically right here, it's about to execute this line. This button right here, step into, we can keep clicking that. You will see that this arrow will move sequentially it will move through our program line by line. And so of course step into once again will mean it will execute that line of code or that statement on that line. We'll go through this for loop a couple of times. At this point, we are not concerned with the values, how they change or anything. We are mainly concerned with what these buttons do. Go through those once again. You can see now execution jumped to over here. So we are done with the for loop now. Okay, next what we want to do is we want to move to this line and call that function. So I'll just keep stepping into that. Execution is now on this line. I'll click step into one more time. That will jump to this function now. You can see login. This is just a quick silly function that I'm using for demonstration purposes. So execution is right over here now. I'll do one more. And now we are at the start of this line. If I bring up the console window, we have not printed out that variable yet. So once again, this arrow is on this line, but we have not executed this yet. If I click step into now, it's going to step into that line or basically execute whatever statements are on that line. Click step into again. You can press F11 if you want as well. Now if I bring up the console, you can see that has printed out 6. We are right at the end of that function, that closing bracket, curly bracket. So if I click step into now, it's going to exit that function. Click again and eventually we are going to return. Now instead of clicking stop, what you can do at this point is click restart, but I'll just continue here to show you that it's going to close the program. So step into, going to return once again, and it's going to exit. I'll just close this off. So we are now back in the debugger. Okay, so let's say I don't want to step through this entire for loop once again. There are a few things that we can do. Firstly, we can set another breakpoint. So I'll just go maybe down here, left click to do another breakpoint. Then I can click continue, because I'll just remove that. If I click continue, it's going to execute the rest of the program, as you can see right here. I'll just run that once more. So now I'll go and add a breakpoint on this line. And if I click continue now, it will execute the rest of the code following that breakpoint. And then it will notice another breakpoint right here, and it's just going to stop or pause basically right on this line. Now, as I mentioned previously, if I now click step into, it's going to jump to that function, which is up here. So that's fine for this example. Let's just do that. So I'll step into that once more. And let's say I click that accidentally, or maybe I have a few statements up here that I want to check out to see like what's going on and how execution works. Because once again, you can do this with if-else statements, loops, and various other things, right? So this is a way of seeing the sequence of instructions and how that executes. Let's say, okay, I'm done with this function now. I've seen what I wanted to see. I don't want to now step through all of the statements within that function. What we can do is we can step out. That once again is going to return to the calling function or the caller, which in this case is main. I'll click step out. And as you can see, if I bring up the console, that will print out 6. The program is not done yet. You can see we don't have return 0 or anything. So what I can do is I can keep stepping a few more times, and that is now exited with code 0. Alright, I'll do one more time. Click continue. It will go and execute that code. We don't have to click step into on each line, right? Now at this point, let's say we don't want to step into that at all. In this case, we just want to skip that. Our function works the way we want. Our bug is not in that function, for example. We just want to move on to the rest of whatever is going on in our code. Well, for that, we step over that. So I'll step over, bring up the console window. You can see it still executes the code or the statements within that function body. So it's printing out 6. It's going to do x, pass x in here. It's going to print that out. But once again, we do not have to step through each statement within that function. And now we can continue stepping through the rest of our code. I'll remove that breakpoint for right now, and I'll run once again. Okay, so now we don't have that breakpoint. Of course, you can add one, but there's another option. I'll hover my mouse cursor on this line, and you'll see we get this kind of play bar, similar to what you have on a media player or something like that. You'll see that this says run execution to here, meaning that it's going to move execution of the program, so that arrow, to this line. Left click on that. The execution jumps to over here now. And now I can continue to execute, so step into those lines. In this case, I'm going to step out of that function. We can now go and restart. Instead of stopping and clicking debug, we can simply restart. And now we are back up here again. I'll scroll up a bit, hover over here and left click. Now execution will jump to right over here. The rest of our code executed, right? It did not skip that code. I can step into that. It will print that out, which will be 6 once again. And I'll just stop that. That is a quick look at those options that we have. Again, step into, step over, and step out. You can temporarily disable one of these breakpoints. If you hover over it, you'll see that you get this menu, this context menu. If you click disable breakpoint, you can also right click on it, and then you can delete or enable or disable. Let's say we want to pause execution on this line. You can click right over here. So I'll just do that quickly. Execution will pause on this line now, and it will ignore that breakpoint. I'll just remove that, just delete that. You can simply left click to add and remove, or right click and delete as well. Okay, so let's say we want to quickly debug our program and jump to a particular line. So let's say this line. I'll right click on this line. Of course, you have options to insert a breakpoint and so on. But what you can do also is you can run to cursor, that is Control F10. What that's going to do is it's going to essentially insert a temporary breakpoint. So it's going to run the program in debug mode, and it's going to break or basically pause on that line. Let's just see how this works. It will go and pause on that line. Now we can decide to step into those lines and so forth. I'll just stop and I'll go and enable that once again, and then I'll right click on this line and run to cursor. And what you'll see is it will now actually go to this line. So what's going to happen is it's going to see this first breakpoint. It's not going to skip that just because we use that option in the context menu. Even though we don't see it, we basically have a temporary breakpoint on this line now. So what we can do is you can click continue. That's now going to be F5. Continue or F5, right? So I'll just go, click continue. The execution will now jump to that line. If I click continue now, it's actually just going to execute the rest of the program and exit, as you can see right here. So that is the run to cursor option. We've already discussed how breakpoints are useful for stepping through our program. This allows us to see whether or not our for loops execute as we might expect, or whether or not some other branch of code is getting run, so switch statements, if-else statements, and so forth. But it's also important for us as programmers to gain an understanding of the state of the program while it is running, so the state in memory. And the debugging tools really allows us to understand what is going on in memory. So when we have a breakpoint, once again, this indicates to Visual Studio where it should suspend our program or the running code, so that we as the developers can go and inspect or look at the values of variables or the behavior of memory. So this is the next thing that I want to discuss. We've already talked about how we can step through our code. So next what I want to look at is how we can go and inspect the memory or the values that are stored in variables, basically. Previously I've shown you that let's say you hover over a variable such as here, int x, you can see that x is an integer. Similar over here, let's say I hover over this I variable, you can see that this is also an integer. So this is handy in some cases. So let's say you are between floats and doubles. It's easy to distinguish what is going on. If you once again hover over the variable, it will show you whether that is a double or a float. So for example, so just a quick example here, I do the auto keyword that I explained previously. I have temp. You can see this is set to a double. If I hover over temp over here, that temp variable, once again we can see that is a double. And this is thanks to that IntelliSense, or the kind of the real-time debugging that we have going on. If I change this here to an F, then temp is going to change to a float. That is why I discussed this here, the F, so that the compiler can differentiate between floats and doubles. Alright, so we use the F for that. But once again, this allows us to check out what the variable is at that point in time in our program. But it doesn't show us what the value is. It just shows us the type. It would be nice if we could see the state or the value that is stored within that variable in a similar pop-up like this. And we do have data types that will show up in a similar way while paused in the debugger. So I'll left click on here to set a breakpoint and I'll run that. Okay, so we are now paused in the debugger, and now we can hover over an element with the mouse and we can inspect the value. You can see we have this pop-up that shows up. I'll just click over here again and we have a pin, so I can left click on that pin and now we can actually pin that to a particular line. You can move that around. You can see to the left here, if you hover over it, it says X is pinned to line 15. Right, so that just allows you to pin it to that line. You can unpin it again. Now I can move that around. It's not pinned to any particular line. You can click here to expand any comments. You can add comments if you want. So this line is not executed yet. I'll just go and pin that again, actually down here somewhere. This line is not executed, so I can step into that line. This red means that X has changed, so X is now 6. Right, I'll just kind of move that out of the way and I'll go and hover over I and then I'll pin that. You'll see currently it contains garbage, so I'll step into that. Now it's going to set I to 0 and I'll step through a couple more times, and as you step through here you will notice that I changes and updates. Once again, you can pin this to where you want. Alright, I'll go and step out of that for loop. Eventually that Boolean condition will fail and will exit the for loop. And now you'll see this changes. If you hover over this, it says the value of expression may be incorrect. And the problem is that it is out of scope. Basically, I does no longer exist. It doesn't exist anymore, right? So I'll just close that off. You can close it off clicking this button here. Okay, I'll step into that function. And now we'll see we get the same thing with X down here. And the reason is that execution has changed or moved from the main function to this function over here. So we can now inspect Y if we want. I'll continue stepping and eventually we'll return back to the main function, to the calling function, which once again is main. And now you will see that we have X again, and this is now out of scope. The local variable Y has been destroyed at this point, and you can see identifier Y undefined. That's because it doesn't exist anymore, similar to what we had with I, but X exists in this local context. Right, so that is one way of tracking the state of variables, is using this fun menu. And what I like about this is it's right here. You can pin it and you can right click on this and you can clear this if you want using this menu. Or once again, you can click here to close it and it's right here where we are working, right? I'll show you one more example. I'll click over here to set a breakpoint and I'll run the debugger. I'll hover over the X value over here, or actually you can do it right here too, it doesn't really matter. and you can click in this section here to go and change that. So let's set that to 500, for example. You can pin it to if you want. That's bigger in this case. Might just be my settings, but you can change it right here, or you can, with this pop-up here, can change it in the section to the right. So at this point X is 500, right? It is now set to 500. I'd also like to mention once again that it doesn't really matter where you pin this. So it's not going to affect, as you might have noticed. So if I have it here, X is not going to be 5, right? Because we have it here where X is set to 5 or initialized to 5. It all depends on where execution is at currently. So execution is down here. X would have been 6. Of course, I changed X now to 500. So let's look at the console. We can see 0, 1, 2. I'll go and close that off, and I'll step into that function, step into that line right here, and that'll now print out 500. So that's very handy. It allows us, once again, just that extra capability in debugging. If you want to go and change variables whilst we are debugging, instead of having to stop this and then, debug once again, we can do that whilst debugging. And also, it's temporary, of course. It doesn't actually make a permanent change. So if I just go and stop this and maybe run that again, right? X is now once again going to be what it was previously. So those are temporary changes. Data types are really fun. They allow us to inspect our variables in context, so right here where we are working, right? But sometimes we want to see those values in a table format. To the left here, once again, I have this breakpoint, and I'll just go and run the debugger. You will notice these tabs down here. So we have the autos, locals, and watch tab. And to the right, we have the call stack. The autos window will show us all of the variables used in the current line or the preceding couple of lines. Then we have the locals tab, which will show us all of the variables defined in the local scope. Usually the current function or within a code block, so a compound statement, a for loop, and so forth. So what is available within a current scope? We have discussed scope before, and this is a nice way to experiment and see how the scope changes. For the most part, I prefer to work in the locals window, in the locals tab, or in the watch tab. So once again, the locals tab is going to show you the variables that are in scope. Then you have the watch tab. This allows us to specify specific variables that we would like to trace as we go and step through our program. Okay, I'll go to the autos tab, and now I'll go and click the step into a couple of times. And as soon as I reach this line here with the console output, you will see that our X variable will not show up in the auto window. Only I shows up right now. Step into a couple more times. When we reach this line with the header of this for statement, you can see I and X show up. If I step into once again, you can see only I shows up. So it doesn't show us all of the variables that are within scope in the autos window. So once again, for the most part, I prefer the locals window. Here we can see the variables that are within scope. So we have both I and X, and you can notice how they change as we step through the program. So X is currently 6 and I is 1. So I can step into a couple more times. And now I break out of that for loop. We are now at this function at the top here. And if I step into that once again, Y is now in the locals tab, as well as in the autos tab actually. But X and I won't show up because that is not within scope. I'll go and restart that. We can see in the locals here currently X is in scope. The value is 5, and of course that is going to change. As we've seen, similar to the data types, this red is going to indicate that X has changed, so the value has changed. Step into that for loop, and I is going to change. So right after it changes to red here, and then if I step another line, you'll see that color will go away until we make a change again. Now I have stepped outside of that for loop, so the Boolean condition failed. We break out of the for loop, and the variable I is destroyed. That local variable, it no longer exists, and that is reflected in the locals tab. So only X is now available. Alright, I'll restart that once more, and this time I'll go to the watch window. Scroll up just a bit. And before I talk about the watch window too much, what I would like to note is you can right click on the variable, so X for example. Then you can also do something called quick watch. So I'm just showing you this so that you don't get this confused too much. And this will basically now show you the value and everything just like in that table. But this is a modal window. We cannot go and click or do something else. We have to finish up with what we want to do here. So this is not as useful to me as the watch tab down here. But what's cool with this is you can do some expression and then you can reevaluate. And what you can also do from here is you can click add watch, and it will add that to the watch window. So let's say in this case I want to make a change to X. I want to add 3 to that, for debugging purposes. I can do it in this way, and then I can simply go and close this down. Because I've added that to the watch window, that will show up in here now. So we have the original X, then we do X plus 3, and we get the values. You can also, if I right click on I for example, you can also add that to the watch, as you might have noticed. So you can click that and that will add it down here. Or what you can do is you can type in a variable. So I'll type in Y, lowercase if I remember, yeah, that's lowercase. In the value table, you'll notice it shows us those identifiers are undefined. You have this refresh that you can click, but it's going to stay undefined until we reach that scope where it is actually defined. I'll just step into a couple of times. As soon as we reach this line, you can see I is now defined, but it contains garbage. So we have to step into that line. Now it will get assigned that value 0 or initialized to the value 0. I'll keep stepping through it. That will update in the watch table. Alright, now as soon as I step into this function, Y will become available. So I'll step into that. You can see Y is now assigned 6. Now we have this refresh button to the right of X, X plus 3 and I. Now because this is confusing, I can just right click on this here and I can select delete watch. So I can just remove that from this table. So I have X and I. Now I is out of scope. So as soon as we were done with that for statement, I got destroyed once again. So if I click on refresh right here, you can see identify I is undefined. And actually X is undefined in the scope too. So where the execution is at currently, program execution, X does not exist within the scope. Only Y exists within the scope. If X were to be a global variable, so if we had X, up here on line 4, for example, maybe as a constant, then it would be available within this context, so within this function and within the main function. So we've discussed the basics of scope already at this point. And that will print out, if I step into that line, it's going to print out 6 once again. With the closing bracket, what's going to happen is typically the local variables are going to get destroyed and it's going to return to the calling or the parent function. So what I'm going to do is step into, we are going to return to the main function. Now Y is going to be out of scope. You can left click on that, you can see Y is now undefined, but X still has this value 6 in this scope within main. Okay, I'll restart once more. We are still watching these variables. And as with the data tips, we can go and change the values. So let's say I do X, I can double click in here. Do 500, press enter or return to enter that value. And I'll just go and once I reach this function, I'll go and step over. And that will now print out 501. And that's because I set that here and then it did the increment. So in this way you can track what the value of X is. You can change it. Again, that is temporary. So if you restart this, you will see that your X variable is set back to 5. Also, you don't have to go and do a quick watch if you want to do an expression. I showed you how you can type in a custom value for that variable, and you can also do an expression. So I'll actually double click in here to create something new. I'll do something like x multiplied by 2. If you go and do something like x plus I, identifier I is undefined, so I'll have to go and step my execution to that point where I is actually defined. And as you can see, that will now update with that expression. And that will now add those together. So once again, very handy in different situations that you might get into for debugging purposes. I'll just stop that for now. And after stopping that, you'll see once again that this window hangs around. You might want that. You might want to inspect this. But I don't want that window to hang around. So go to Tools, Options, and then under Debugging, scroll down. We have this option, automatically close the console when debugging stops. I'll enable that because what you can do is you can set a breakpoint down here. So I'll run this, run the debugger one more time, click continue so it skips all of that stuff, and now execution is down here. You will notice the window is right here, and when I step through now, that's going to close that window down. Of course, if you go and run the program, so start without debugging, it will run that and it will still ask us press any key to continue before it will close that window. Okay, in personal preference, I prefer to have that closed down each time. Okay, I'd like to briefly mention the call stack. I'll just go and run the debugger once more. So I have this function here, and I'll go and just click continue so I can go to that. And you can see the call stack to the right here. You can ignore some of the other tabs for now. This is a way for us to examine and understand the execution flow of our application. It's going to show the order in which functions are getting called. The top line is going to show the current function. Okay, so what's going to happen is when I step into this function call, that is going to move to the top of this stack. Okay, so I'm going to step into that. You can see execution with this arrow. What's cool here is you hover over that, it says this is the next statement that will be executed. Okay, so I'm just going to look at the call stack once again, and you can see we are now executing or at that function basically. It shows you the project name, so cppdemos.exe currently, and logint is the function name, and it is at line 6. And of course, once we exit that function, it's going to return to this main function down here. So I'll just go and step into that. And that will now get removed from the stack, and now we are back at the main function. So I don't want to spend too much time in the call stack, I just want to mention it. It might be useful for debugging purposes, especially as your program grows in complexity. So we actually have conditions for our breakpoints as well. So I'll set another breakpoint on this line. And then if you hover over it, I showed you this pop-up that you can toggle the breakpoint on and off, or enable and disable it basically. Then you also have the settings menu. Now you can go and choose conditions, so you can add conditions to this. I'll show you one more way to get to that. You can right click on it, on the breakpoint itself, similar options, disable and so on that we've seen already. And then you also have conditions and so forth, a few other things. So I'll click on conditions. Then you have a few options. I'll start with the conditional expression. I'll set that to is true. I'll type in I is equal to 2. If I press enter return, it should accept that. You can actually add multiple conditions here, so you can add another one. You can do hit count, filter, and so forth. I'll just cancel that. You will also notice that the breakpoint changes, the icon changes. We now get a plus in that. Okay, I'll close that off and I'll run. So execution should stop at this line as soon as I is equal to 2. I'll just go and delete that expression that we added. Click continue. So execution is paused on this line now, and we can inspect here I is equal to 2. Of course you can hover over it as well, and at this point you can see that I is equal to 2. Alright, you have a few other ones. So under conditions you can specify this as when changed, and then you can specify, so I for example, you can also do heat count, and then you can do a multiple of, for example, such as 2. So this is useful for a loop to stop execution after a number of hits, so that you don't have to go and step through that loop each time, right? Press enter. I'll just close that, and then I'll go and I'll change that to 10. Click continue. You'll see it stops at I is 1. Remember that we start at 0. So 0 counts as hit, and then 1 is hit as well. And then we go and continue. And of course, that will now go to 3. So 2 more hits and then it stops at 3. Continue 2 more hits, we stop at 5. And we can just continue until we exit. I'll go and change that one more time. Under conditions, I'll set that equal to 5, for example, or let's make that the final one. So 10 here. Press enter. Close that off. Go and run that, and I'll continue. And you can see I is equal to 9. Once again, remember we start at 0 with I, so it is going to hit this one time when I is 0. By the time we have 10 hits on that breakpoint, I is going to be equal to 9. Now you can see I is equal to 10. In this case, this for loop is going to fail, that boolean condition is going to fail, and we are going to break out of it. So that is a quick look at the conditions on the breakpoints. Of course, you have a bunch of other options. I don't want to go into all of them at this point. I just wanted to highlight a couple of them. So I'm just going to delete that breakpoint. You can also set breakpoints on functions. Of course, you can go and click here somewhere to set a breakpoint, but what you can also do is you can go to debug. Here you have the options to toggle a breakpoint. You can step into, step over, and so forth. Alright, then you also have delete all breakpoints. You can disable all breakpoints right here as well. Okay, so I'll go to new breakpoint and function breakpoint. And then I'll go and type out the name logint, and I'll go and add what that function takes in. So in this case, an integer. You can hover over this to read the information on that. Especially for C++, it's important to write fully qualified names for your functions. I actually tested it just like this, so this worked fine. I'll just click OK, and we'll see if that works. So I'll click continue. That will now break right over here. I'll stop debugging, once again debug, new breakpoint, function breakpoint. So this should work too. Here you also have conditions and stuff, but for right now I'll just leave those alone. Click OK, and that should work fine. You can see that the breakpoint shows up. Alright, where can we see a list of our breakpoints? Because we might have many of those. To see that, I'll go to debug, and we have Windows and breakpoints. So if that is not already open, that is where you can find it. The login shows up twice. You can right click on it. You can disable it. You can enable or disable that particular breakpoint, similar to how you can do using these toggles right here. Clicking in this first column, those checkboxes. So that is very handy. Now that the debugger is running, I'd like to show you one final thing, and that is you can right click on this value here, so X. I'll right click on X here, and then you can click break when value changes. So I'll select that, and you'll actually see in the breakpoints window, it will specify the condition. So when original expression x changes. Alright, so I'll go and step into that line now. The following breakpoint was hit. I'll just close that. So x has changed because of the increment operator. That is why we hit that breakpoint. Alright, I think that is going to wrap up this video. I showed you quite a few things, so go and play around with these features. You might need them at some point. Now, as we go along, especially when I talk about pointers again in Module 102 and some of the other language features, we'll probably make use of the debugging features of Visual Studio once again, where I'll show you a few more tips and tricks. Okay, so I hope you found this useful, and I'll see you in the next video.